Hello and welcome to this math lesson. We're looking at the logarithmic laws. This time we're looking at changing bases. What do I mean by changing bases? Well, let me show you what the law says, and then you might understand. If I have a logarithm, okay, with a certain base and an input of a, which is the result of taking b to the power of e, we know that if we have a base exponent equal to an answer, this is called the exponential form, and this is called the logarithmic form. And all that happens is that the input is the answer. So the question is, base, what exponent must I give you to get a as an answer? And that is the value for log with this base equal to e. But what we want to do is change the base into having a different base, any other base. Okay, and this law says we're allowed to do that with the following expression. We can change it to any other base. Let's take a base c, whatever c represents, and then the input of the numerator is the original input here. But in the denominator, so this, to change the base, turns it into a fraction, where the numerator's base is now the base we want to change into. Its input is the original answer, and the original base becomes the input for the denominator. So very important. This order, of course, is very important. To change the base, I write a logarithm over a logarithm, with the new base as the base for the numerator and the denominator, and the input for the numerator was the original input, and the input for the denominator was the original base. Okay, it's as easy as that. Let's quickly go and have a look at the proof. This proof is not so simple. You might want to watch it a few times just to see what's happening. Okay, so let's start by starting with that expression that if we have a base and an exponent and we get this answer, this is the exponential and this is the logarithmic. The log of base a equal to e. We get this. Okay, now something that might seem a little bit odd. Now we want to change the base to c. So I want a different base, but I still want the same answer. Can I still just use the same exponent? Well, of course not. Okay, if I want the same answer with a different base, I'm going to have to take a different exponent. Let's call that exponent for now n. Okay, now this one would be log base c of a needs exponent n, c to the power of n is equal to a. Okay, and now what I'm going to do is find an expression for this in terms of this n and that e. Okay, so let me start by saying the following. Okay, since we know that b to the power of e gives me the same answer as c to the power of n. Okay, what I'm trying to do is just solve for b. I'm trying to get b on his own, and a little bit later you'll learn more about this, but for now just look at what I'm doing. Okay, if I then take b to the power of e and put it inside a root, the e'th root, okay, I'll get the same answer as if I put c to the power of n in that e'th root. Do you agree? Because b to the power of e gives me the same answer as c to the power of n. So if I put this in an e root, I would get the same answer, and that's why there's an equal if I put this in an e root. So what I get here is that b to the power of e divided by e is equal to c to the power e over n. No, I lie. N over e. N over e. Okay, so in the end what I have is I have now a way of finding b is equal to c to the power of n over e. In other words, I've got a new exponential expression where this time my answer is my original base. And that's what I want, because I'm trying to get this expression. I want the input. So what must be the exponent if for C to get an answer of B? Well, this is what the exponent needs to be. N divided by E. So whatever N was, that's the exponent I have to give C to get A. If I divide N with the exponent of E, with E, and E was the exponent, I needed to make B equal to A. So I know this must be very confusing to some of you, but if you watch it a few times, you might follow it. Okay, so if I go and change this into a logarithmic form, I get that log of base C gives me an answer of B if I give C an exponent of N over E. Okay, so here is where I want to say this is where the tricky part starts. You've got two ways to work it now. Since you've got an expression for this and this, we can start with this and work backwards to get this answer, to show that it's true. What I want to do is I want to start with this and see if I can get that expression. So I'm not there yet, but I'm close. So how am I going to do it? Well, I want to change log of base with answer inside equal to, now I know it is equal to E. That was what we had from the very beginning. That log of base answer is equal to E. That was what we started with. Okay, and now I want to change it to get the following. I want an N and I want an N over E. How am I going to get that right? Well, what I'm going to do is I'm going to multiply E with N, but I'm not allowed to do that unless I also divide with E with N. So I'm also going to divide E with N. Okay, so now I've got a numerator and a denominator. And now what I'm also going to do in this numerator and denominator, I'm going to divide the numerator with E, as long as I also divide the denominator with E. You remember when we did fractions that you're allowed to multiply and divide numerators as long as you do it to both of them. So let's simplify. What do we have now? So we have log of BA is equal to, and here we have E divided by E is just 1. So I've got N left in the numerator, and in the denominator I've got left N over E. Okay, but I know what N is. Remember what N was? Right in the beginning we said N is the exponent I should give C to equal A. So N is the log base C of A. So I can replace that. N can be replaced with log base C of A. And the denominator is N over E. And that's what I have here. N over E is the exponent I should give C to get B. So N over E is log base C of B. And there I go. This is my proof. Here I have the proof that log base of A is the same as taking log of a different base of the original input divided by log of a new base with the original base as an input. Okay, so just quickly, and I'm not going to spend much time on this. Why would we want to do that? Well, there's two very good reasons. The one is that sometimes we want to change bases just for the type of work we are doing. Working with a base 10, or base E. Okay, base E is not something you'll know yet, but working with these two bases are very common when it comes to the math world. Now, it's so common because computers are programmed not to calculate any base. a computer can't program any, isn't programmed to do any base unless you program it to do so. But a computer is programmed to do base 10. Okay, a computer is programmed base 10. So when you wanted a computer, or if you're writing a computer program and you wanted it to calculate the logarithm of any base with an answer, you will have to change the bases to base 10, so that you will have to change it to log base divided by, sorry, I'm lying, log input divided by log base. Okay, so that you're going to have to do that. So some calculators, the newer calculators, can calculate any base. They've been programmed to do that, but older calculators, that like the one I use, can't. So if I have a question and I had to say log of 2 10, what exponent must I give 2 to get 10? Well, I can't do that in my head. I have to change it to log 10 divided by log 2. And let me actually show you, the computer calculator does it as well. As you can see, this calculator on Windows, the only logarithm that we have on here is this log. It doesn't have a specific base, which means we can only calculate base 10. Okay, but that's not a problem. If I had to calculate log with base 2 of a certain value, all I do is take the log of the value I need to calculate. So in this case, I type first 10 log, okay, which takes log of 10, divided by, and now log of 2, which is the original base, divided by 2 log. So if I press equal, it gives me the answer of log 10 divided by log 2, and that is approximately 3.322. So this is approximately 3.322. Let's go test that. Is it true that 2 to the power of 3.322 is approximately equal to 10? And let's test that. So 2 to the power of 3.322 is equal to, there we go, it is. It's almost 10. It's got a bunch of digits that if we definitely round, we get to 10. So this is true, that 2 to the power of 3.322 is approximately 10. This is where I'm going to stop this. You'll see there's not many applications for this in the course we're doing, but one important application is the way of changing a base into a base 10. Which is very common actually. So thank you for watching. I hope you enjoyed it. Hope it made sense eventually. I'll see you in the next video.